Hello dear students of class 10, hope you are doing great. I'm so glad to see that you all are interested in learning physics. In today's video, I am presenting the solutions of periodic test 2, set B. The idea behind making all this video is that you practice physics numerical more and more. I want not a single child in my classroom to be left behind. So these videos are going to help my weakest child in the classroom to revisit those concepts which were done in classroom, relearn the concepts and score full in the coming examination. So let's get started. Let's see the questions which were asked in the set B. So the questions are on the screen, and those students who are watching from other schools, you can take a screenshot of the question, pause the video, do the sums and come back after 20 minutes and check the solutions if your answers are correct or not. So without any further delay, let's get started. Question number 1 is to find the least count of the voltmeter as shown in the figure. We had similar question in set A. So those who have watched set A, this does not mean that you should not watch the solutions of set B. These are your questions and you should know the solutions of all the questions. So let's see the question number 1. Find the least count of the voltmeter as shown in the figure. So how to find the least count? To find the least count, we should know a concept of range of any instrument. So what is the range of the voltmeter? This is voltmeter. This V indicates that it's a voltmeter. And well, there is a symbol over here which is like tilde, and sometimes you'll find a symbol like this which is dash. These two also represents different things. This one is for AC and this is for DC. We are not getting into AC voltmeter, DC voltmeter, but you should know the symbol what they represent. Okay, so this is a voltmeter, let's say, and we want to find the range of the voltmeter. So here if you see the range, the reading starts from 0 and goes to 100, then 200 and 300. So the maximum reading that you can take from this instrument is 300. So we say the range is 0 to 300 and take care of the unit, it will be volt. This is the range. Now in order to find the least count, LEAST, least count, sometimes I write in short as LC, least count. To find the least count, you have to see this 300 division, right? 300 volt is divided into how many parts? So that is the total number of divisions, the total number of divisions. So if you count the divisions, it's like 1 2 3 4 5 6 7 8 9 10, and again 11 12 13 14 15 16 17 18 19 20. You got it? This is 10 20 30. So this 300 volt is divided in 30 parts. This is 300 volt divided by 30, and this gives you the answer as how much? 10 volt. So here each division means how much? 10 volt. The other way of solving this, if you don't want to take the entire range from 0 to 300, you can actually take a portion of the graph. You can see over here I have zoomed this portion. Okay, this portion is zoomed over here from 0 to 100. So if you see the range from 0 to 100, we have got 10 division, 1 2 3 4 5 6 7 8 9 10, which means that 100 volt is divided in 10 parts. So each division, the measure of each division, that is this much. What is this? The measure of this one division is equals to 100 volt by 10, and that is equals to 10 volt. This is the answer of the first question. In class 10, the formulas are not necessary. You just write this 100 volt by 10 and write 10 volt. That's the answer of question number 1. Let's see the solution of question number 2. The question number 2, draw a labeled circuit diagram to verify Ohm's law. I have given the solution of this question in set A as well. Here I am presenting a little different answer. How can you draw the circuit? So you can see here, in order to verify Ohm's law, we have one resistor, which is a fixed resistor over here, and we are supposed to find the value of this fixed resistor. The value of this fixed resistor. So what we basically do is we connect one voltmeter across the resistor. So this voltmeter is connected in parallel, you can see. This is connected in parallel to the resistor, and one ammeter is connected. And this is a cell. But this circuit is fixed. We cannot vary the voltage or vary the current. So this will give you one reading. But while doing the experiment, we are supposed to take series of observations, maybe 5 or 6. So in order to get more observations, we need to vary current or voltage in the circuit. So in order to do that, what we basically do here, one more thing, you see there was no switch in the circuit, so we need to put one plug key or a switch. So in lab you must have seen this is a plug key. This is called the key, and the base is called, the whole thing is called the plug. So we can draw the symbol of plug key over here, that is in the circuit, and the function of plug key is just like a switch. When the key is in the plug, the circuit will be closed, and when key is removed, the circuit will be open. And we have to connect this rheostat, RHEOSTAT, which is also the variable resistor. So when we slide this, you can see the slider, when we slide this, the resistance will vary from 0 to 65, for example I am writing here. So resistance can vary in the range from 0 to 65. In lab you may have a rheostat of different range, and that's okay. So how do we represent the rheostat? You make the resistor over here like this, and this has got two terminals like this, and the third terminal is over here where we are connecting the slider. Okay, this represents the rheostat or variable resistor, and this is a circuit to verify Ohm's law. I hope you can draw it on your own next time. Take care of the polarity plus and minus. If you start from the positive end of the battery, connect the positive of ammeter and then the positive of voltmeter. Okay, now let's get into question number 3. An easy question. I saw most of the students getting this question right. The question was, what is the maximum and minimum resistance that can be obtained by connecting 4 resistors of 15 ohm, 15 ohm, 30 ohm and 30 ohm. So we have got 4 resistors and we have to find maximum and minimum resistance. So for maximum resistance, we all know we have to connect the resistors in series, right? For maximum resistance, we'll connect all of them in series. So for resistor 1, in any order you can connect, not necessarily like given in the same order, but they should be in series. So when you connect them in series, so this is 15 ohm, this is 15 ohm, should I mention ohm? Yes, 15 ohm, 30 ohm and 30 ohm. So if you find the equivalent resistance, I can call this as RS because they all are in series. So if I add them, this is 15 ohm plus 15 ohm plus 30 ohm plus 30 ohm, and that's going to be 90 ohm. I'm surprised to see that students sometimes do the addition wrong in class 10. They write 60. Please check your calculations very thoroughly. Now second part of the question says to obtain the minimum resistance. How can we obtain the minimum resistance? This is from the concept of parallel circuit. When you connect the resistors in parallel, you get the minimum resistance for the circuit. So we have got 4 resistors. If we connect them in parallel, the circuit is not looking so good, but I hope you can understand. And I connect them. These two ends represents that they are connected to the battery. Further they will be connected to the battery. Okay, so sometimes we don't even represent or draw that entire circuit. So let the values be 15 ohm here, 15 ohm, 15 ohm, 15 ohm, sorry, 30 ohm and 30 ohm. So in this particular question, we are not only supposed to show the connection diagram, but we are also supposed to find that maximum and minimum resistance. So for this particular question, answer is 90. So we also need to show the calculation for this circuit. Now calculation can be done in two ways. For the parallel circuit, so I am writing here for minimum resistance, we connect the resistors in parallel. We can even write this. For minimum resistance, we connect them in parallel. Now there are two ways of calculating this. If you go by the general method, you say 1 by Rp is equals to 1 by R1, that is 1 by 15 plus 1 by 15, 1 by R2, 1 by R3 and 1 by R4. If you solve it like this, you get the answer LCM as 30, and from here you can say this is 2 plus 2 plus 1 plus 1, and that gives you 6 by 30. You can simplify this is 1 by 5, and from here says 1 by Rp is 1 by 5, which means Rp is 5 ohm. It's very easy. Now if you want to calculate this in a different way mentally, you can see there are two resistors in parallel, both are 15 ohm. Okay, not like this. I'll take the other way. I'll take the equivalent of 30 and 30. The equivalent of 30 and 30 will be 15, because both are equal, so the resistance will be half. So equivalent of 30 and 30 will give you 15 ohm, and this 15 ohm along with the two other resistance 15. So there are three resistors of 15 ohm in parallel. So then R equivalent will be that 15 ohm divided by 3, that is also going to give you 5 ohm. So this is the trick you can apply to make the question quickly. I hope this solution is clear to all. Let's now go to question number 4. Okay, this was the typical question, or you can say the hardest question on the paper, but most of you have done, but still half of the students I found are struggling with the solutions. So I'm again going to give two methods to solve this particular question. If you see, all the information is given in the circuit. So in the question says, in the given circuit, determine the value of voltmeter. Means we are supposed to find this voltmeter. If the reading of ammeter is 2 ampere, it is given over here, and what is the value of R2? We are also supposed to find the value of R2. Now if the circuit looks complicated because of so many symbols or information, you need to redraw the question in exam. And when you redraw the circuit, try to remove all the extra ammeters and voltmeters. Keep only resistor and power source, the battery in the circuit. This is going to make the circuit looks very easy, because I see students getting confused with R2 and R3 here. Are they in series or are they in parallel? So it's important to understand. You remove the ammeter and voltmeter and just see that the resistors are in series. So this is R1, this is R2 and this is R3. So how can we find the value of R2? This is in method 1. I am going to find the value of R2 and then I will find the value of voltage. So here if I apply the formula for equivalent resistance, equivalent resistance RS is equals to R1 plus R2 plus R3, since they all are in series. This is equals to R1 is how much? 10 ohm. R2 is not known to us, this is what we have to find, and R3 is given 15 ohm. So if I know the value of RS, if I can find the value of RS by some other formula, I will be able to find the value of R2. So how can I find RS? If we simplified this circuit into a simple circuit like this, This will be called R series, and we'll have a power source, and the circuit would look like this. And the current that is flowing is 2 ampere as it is given in the question. This current is 2 ampere, and the voltage supplied is 60 volts. So from this circuit we can find the value of RS. RS will be equals to voltage that is supplied by the current. So this is 60 volt divided by 2 ampere, and that is going to give 30 ohm. And now we can put the value of 30 over here. So this is 30 ohm is equals to 10 ohm plus R2 plus 15, and from here you can easily see the calculation. This is going to be R2, it will be equals to 30 minus 10 minus 15, and that is 5 ohm. Okay, so you got the value of R2, and if you got the value of R2, you can now find the value of R3 also very easily. How to find the value of voltage here? This is given here 15 ohm, right? And you know this is a series circuit. So if current flowing over here is 2 ampere, the current flowing over here is also 2 ampere, here is also 2 ampere. Now over here sometimes you get confused whether the current that is going over here will all go here or there will be branching. So for class 10 students, I want you to remember that no currents goes to voltmeter, but this is not possible. A very small amount of current though passes through the voltmeter, but it is very, very small. So we assume that entire current is flowing through the resistor here, okay, because the voltmeter has very, very high resistance. So current do not want to flow through the voltmeter. So in order to find the V, we know the formula here, V is equals to I into R, and since we are finding the voltmeter reading of the third resistor, you can call V3 is equals to I into R3, and from here you can get the answer. The reading of voltmeter will be the current, that is 2 ampere, multiplied by the resistance, that is 15 ohm, and that is 30 volt. So this is the method 1, where I have calculated the resistance R2, and then I have calculated the voltmeter reading, that is 30 volt. Now there is another method. In the second method, I am going to calculate the reading of the voltmeter. So I'll again write the information. This is 10 ohm. Here I am writing the information. The question says this is 10 ohm, and this is 2 ampere current, and this value is R2, that is not known to us. This is R3, 15 ohm, this is R3, and this is R1, and this is 60 volt supply, and we have to find the value of this voltmeter. So in this method, what I do is we know that we are supplying 60 volt, and in series circuit, you know, the voltage gets divided proportionally. So what is the voltage across R1? I am supplying 60 volts. So what is the voltage across R1? So I can say voltage across R1 as V1. If I call this as V1, and that will be equals to I into R1. So if you put the value of I, which is 2 ampere multiplied by 10 ohm, you get 20 volts. So we are supplying 20 volt over here. For this, V2 will be equals to how much? You can see V2, if I want to calculate, V2 will be I into R2 from simple Ohm's law. The value of current is 2 ampere, but the value of R2 is not known, so we cannot find V2. We cannot find V2. We will come to this later now. Let us see how we can find V3. V3 will be equals to I into R3, that is 2 ampere multiplied by 15 ohm, and that is going to give 30 volt. This was the solution. This is the question even asked. We can even find this is V3. This was asked, so we got one answer over here. V3 is equals to 30 volt. Okay. Now from the concept of series circuit, you know, since we are supplying here 60 volt and the resistor 1 is getting 20 volt, resistor 3 is getting 30 volt, and this is V2. So we know this is V1 plus V2 plus V3. V1 plus V2 plus V3 is equals to Vs, that is what we are supplying in the series circuit. Means 60 volt got divided into V1 plus V2 plus V3. So here if I put the value of V1 as 20 volt, V2 is not known, and V3 is 30 volt, and Vs is 60. So from here we can find the value of V2 first, and V2 will be 60 volt minus 30 volt minus 20 volt, and that is 10 volt. So we got the value of V2, and now what we can do is we can replace the value of V2 over here and write V2 as 10 volt, and that is A's current is 2 ampere, and from here we can calculate the value of R2. So R2 will be equals to 10 volt by 2 ampere, and that is equals to 5 ohm. So I have seen both the solutions done by students in class 10. So I am very happy to see that students are able to find the solution in more than one method, and both the methods are equally correct, and they are going to give you full marks. Now coming to the last question, that is number 5. Write 2 points of difference between series circuit and parallel circuit. In the first video I have given the differences based on the 2 criteria, that was current and voltage. So I have differentiated already in the first video how you can differentiate series circuit and parallel circuit on the basis of the current and voltage in the circuit. Now here I am going to give you the third. You can write any 2 in the exam, but since I have discussed the first 2, I am not discussing in this video. You can watch the first video. So here I am taking the third difference with respect to resistance. Okay, so if I discuss what happens to the resistance in series circuit and parallel circuit, since you are connecting the resistors one after another in series circuit, the R series, if you see, it is equals to R1 plus R2 plus R3, and if there are n resistors, then you can write here plus Rn. So in series circuit, the overall resistance actually increases because it is the algebraic sum of all the resistances. In case of parallel circuit, the resistance we calculate like this: 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Like this, if there are n resistors, then it is 1 by Rn. So if you compare Rp with any resistor, with R1, R2, R3, you will find that Rp is smaller than all the values that is in the circuit. So you can say the equivalent resistance that we are obtaining in the parallel circuit is smaller than the smallest value. So if the smallest value in the circuit was 10, then Rp is going to be smaller than 10 only. So this is the advantage of parallel circuit. You can reduce the overall resistance. Okay, so this is one of the difference I wanted to talk in series and parallel. And yes, sometimes I see children writing in series circuit, if we are using one switch, if we apply one switch, then and let's say we have got bulbs connected in series, then all the bulbs get switched off. Okay, if one switch is on, then all the appliances are on. If one is off, all others are off. While in case of parallel, we can control the circuits individually by using multiple switches. So this is also an important difference you can write, that in case of parallel circuit, we can control each appliances or devices individually by using individual switches for them. Okay, so this is all about the differences between series circuit and parallel circuit. So that's all for today's video. All the very best and happy studies. See you in the next video.